Hello, I'm Professor John Kelly and this is the Weber Auto YouTube channel. In this episode we are going to look at the components, parts, and operation of inverters and converters in hybrid vehicles. The inverters and converters in electric vehicles are very similar, and we will take a look at those in later episodes. But for now, let's take a look at the inverter-converter assembly in this 2010 Toyota Prius that we've used in previous videos. I shot a previous video on a low voltage system on a Toyota Prius, and you can see that clicking on this link. And I shot a previous video on the high voltage system where we looked at the high voltage nickel metal hydride battery in this same series of vehicles, the Priuses, and you can see that by clicking on this link. In those previous videos we looked at the battery location and how the battery works, what it does. We looked at the 16-foot long cable that goes from the battery up here to the inverter with converter. And today we are going to learn how to safely test to see if we can disconnect that and get this inverter-converter assembly out and take a look at it. So the first step before we can disconnect any cables up here and remove the inverter with converter is to depower the high voltage system on the vehicle. Now, if the system is working properly, with the power button off on the vehicle or the key off on whatever vehicle you're working on, it should be depowered anyway. But you always must verify, and you should be using your personal protective equipment, high voltage gloves, and whatever else is necessary for what you will be doing on that particular vehicle. And I have a separate video on personal protective equipment that you can see by clicking on this link. So the first step is to make sure the car is depowered. Turn the key off, hit the power button, shut it off, get the key fob out of the vehicle. There's the key fob. I'm just going to set it over here on the bench, get it out of the way. Alright, now that we have the power turned off and the key fob out of the vehicle, we need to disconnect the low voltage battery wherever that is on the vehicle. On this particular vehicle, it's in the trunk area. So let's disconnect the negative cable. Okay, here we are in the trunk area. And right here under this cover is our low voltage battery. And our negative cable is just right there. So we'll come in and just loosen up that nut and take the negative battery cable off of the battery. And then while we're back here, right here on the high voltage battery, we will reach over and pull over on the service plug grip, rock it back, and then pull straight out. So we've got that removed, which depowers the battery internally. Okay, with our service plug grip removed, now we can come to the top of the inverter with converter assembly. And right on the top of this assembly is this black cover right here. There are 9 bolts holding this black cover down. We have to remove that cover before we can access the electrical connections to disconnect the high voltage battery, the 2 wires from the high voltage battery that we looked at in the previous episode on high voltage. This cover also has one of those high voltage interlock connectors on it. Okay, we've got all the bolts out of the cover. If we lift up on the cover here, you can see the high voltage interlock connector. It's just 2 terminals that plug in over here on the side that completes the interlock circuit when it's plugged in, but when we remove it, it's opened. And if the system were still powered up somehow, even though we've got the 12-volt battery disconnected, the service plug grip removed, if for some reason it stayed powered up, the interlock circuit should notify the high voltage ECU, the computer in charge of the high voltage system, to open the contactors and remove the voltage from the 2 wires that come up here to the inverter converter. In the last episode on high voltage hybrid and electric vehicle systems, we looked at the hybrid battery junction block that's inside of the battery case in the back of this vehicle. And we saw that there was a negative and a positive contactor and a pre-charge contactor and a pre-charge resistor. And I commented that the difference between a contactor and a relay is that a relay just opens and closes one set of contacts, where a contactor opens and closes 2 sets of contacts at the same time. And I had some people comment that they weren't sure that that was true. And so I took the cover off of the negative contactor, and I want to show you what it looks like inside here. So what you're looking at there are the 2 ends, the 2 contactor ends. Inside of this ceramic housing right here are the 2 contactors that we talked about that make and break connection with these 2 terminal ends that stick out the bottom of the contactor and plug into the hybrid battery junction block. I want you to see on the coil side of things that it has both a pull-in coil and a hold-in coil, much like a starter solenoid, which is also a contactor, and it's all hermetically sealed. It keeps oxygen and moisture away from those contacts, so they should last a long time. But that is a contactor with 2 contacts being open and closed at the same time, where if you've ever looked inside a relay, it's just 1 set of contacts opening and closing. Okay, so when you disconnect this high voltage interlock circuit, it is supposed to open all of the contactors. Let's say you forgot to disconnect the 12-volt battery, and you pull that cover off, the contactors should go open immediately if they were closed. But they shouldn't be closed with the power off on the vehicle. But maybe you've got a contactor that's stuck, and so you always need, as I said before, your personal protective equipment. And then the very next step is to check to make sure that you can take off your high voltage gloves and just use regular tools and bare skin on the rest of the inverter converter removal. And the way you do that is you take a multimeter. So I've got my Fluke 87 multimeter here, which is a category 3 meter, which category 3 is it's rated for 3-phase high voltage circuits up to 1000 volts on industrial equipment. And we're going to go in, and on the 2 wires coming from the battery where they go into the inverter converter, we are going to just measure their voltage. Now remember, it's a 201.6 volt battery back there, and if the contactors were open, we would read, or we should read 0. And we are reading 0 volts DC. It's a DC battery. Now if those contactors were both closed, the negative contactor for the negative cable, the positive contactor for the positive cable, so they would both have to be closed at exactly the same time for us to get any voltage here. So there's no voltage there. That means the contactors are open. But let's just make sure we don't have any connection to ground of the chassis anywhere. So we'll just go to the case of the chassis, and we still get 0 volts there. And so that was on one of the 2 wires from the battery. So now I'll go back to the other terminal and go to the case on the other one, and we are still at 0 volts. So that means there is no voltage, there's no power on either of those two wires. So we also have two other electrical connectors with orange wiring on them. They have 3 wires per connector. Those are 3-phase AC, not DC. These are AC voltage wires. And they will only have voltage on them and be able to provide current if the engine is running or about to start running. The middle connector here is for MG1 in the P410 transaxle. That is what starts the engine and what acts as a generator to charge the high voltage battery as you just sit here idling or as you drive down the road. The end connector here is for MG2, which is the traction motor in this transaxle that moves the vehicle down the road, either by itself or with the assistance of the internal combustion engine through the power split device. So these are AC voltages. The engine is off. There should be no power on any of those, but just to be safe, let's check it all. I had somebody comment in a previous video on high voltage that the meter leads I was using that had the long tips no longer met the Category 3 requirements under the IEC, the International Electrotechnical Committee standards, and they needed to be these short little tips here for a Category 3 up to 1000 volt 3-phase AC. And I looked that up, and he was absolutely right. The older meter leads that say Category 3 on them, they did meet the Cat 3 specs back on a previous standard, but the newer standard requires these shorter tips, which provides more safety. There's less area there for flashover, arcing, accidental finger touches, and so on. So we're just going to check on DC. We'll go from each terminal to terminal, 0, 0, 0. Each terminal to the case, 0, 0, 0. Same thing on the other. 2 outsides together, inside to outside, inside to outside, outside to case, middle to case, outside to case. They're all 0. So there is no dangerous voltage on these terminals, and we can now unscrew them and disconnect the wires from the inverter converter. Also, on the disconnecting the inverter converter, there are 7 wire harnesses that connect to this thing. We've got the battery, the high voltage battery, we've got the 2 connectors for the electric motors, we've got the DC output power, we have a connection to the HV ECU, a connection to the transaxle, and then 2 coolant hose connections. One of them goes from the driver's side of the inverter converter up to the coolant reservoir for the electronics. The other one goes down to the transmission. And the path is from the reservoir to the inverter to the transmission, down to the dedicated section of cooling in the radiator, and then back to the coolant reservoir. All right, well, let's go over to the bench where I already have one of these removed, and along with a bunch of other inverters with converters on some. And we'll look at the original converter with inverter from the 2001 through 2003 Prius here in the United States. I told you in the very first episode in this series that I thought the original 1998 Toyota Prius from Japan is what everybody else has based their hybrid vehicle design and platform on. And by looking at and understanding that original Prius, which we have a 2002 here in the shop, so 2001 through 2003 were the first here in the United States, we will look at the original inverter converter there, and then we'll look at the other inverter converters, and you'll see that they all have the same parts. They're not made by the same people. They're not made to handle the same amount of power. They look different, but what they do is exactly the same. So if you can understand that one, then you can understand the rest of them. All right, well, let's go over to the workbenches. Okay, here on the bench I have 7 different inverter converter assemblies. The only one I didn't get out that I do have is a Honda one, and we'll look at that in a different episode on Honda hybrid vehicles. But let's start with here on the end of the table. These two parts right here are the first generation Chevrolet Volt. So 2011 through 2015 Chevrolet Volt. What I have here is a inverter assembly only without the DC to DC converter. So if you recall, the DC to DC converter is basically the charging system for the low voltage system on a hybrid or an electric vehicle. So the inverter, its job is to drive the electric motor or motors in the transmission, or if it's sandwiched in between the engine and the regular transmission, or whatever it may be, it will have some sort of an electric motor that the inverter drives. So this is the 2013 Chevrolet Volt inverter, and the Volt transaxle, the 4ET50, has two electric motors, motor A and motor B, and we will look at those in an episode on Chevrolet. But it has in the back of the vehicle a separate DC to DC converter, which, by the way, in the back of the vehicle is the 12-volt battery for the low voltage system on the Volt. And so it's just right there next to it. The battery is so big underneath the Chevy Volt that they can connect just right there at the battery to run the DC to DC converter. Okay, the next inverter I have here is a 2013 through 2016 Ford Fusion Hybrid inverter only, just like the Chevrolet Volt, inverter only, no DC to DC converter. On the Ford, the DC to DC converter is built into the 1.4 kilowatt hour battery assembly in the trunk, and it is a serviceable component. You can replace that, just like on the Chevy Volt one. You can replace the entire assembly. But Chevrolet does not allow any internal repairs into the inverter or the DC to DC converter. Ford does not allow any internal repairs. And as a matter of fact, Ford doesn't even call it an inverter. They call it the transmission control module, which at first I thought, why did they do that? Because everybody else calls it an inverter. Then I thought, well, it does control the transmission, the HF35 to electric motor transmission. So I guess that is what it does. But I was searching all through Ford service information, trying to find information on an inverter, and I couldn't find it. And eventually I finally found a link that had the word inverter in it, but it led me to the transmission control module, and I looked at a picture of it online, and sure enough, so Ford's inverter assembly is the transmission control module. These two cables right here are what drive the two electric motors in the HF35 transaxle. All right, now the next inverter, and this is an inverter with a DC to DC converter. This one is out of our 2017 Toyota Prius that we just bought earlier this year here at Weber State Automotive. And this has the inverter assembly in the top, and down underneath is the DC to DC converter. And this is a fully serviceable inverter converter assembly. You can buy the intelligent power module, the circuit board that's in the top of this, that interfaces with the high voltage ECU to drive the IGBTs, the big power transistors that run the two electric motors, the MG1 and MG2. And then you can also replace the DC to DC converter in the bottom of this, and you can buy the in-between piece. So really there's only three serviceable pieces here: the DC to DC converter, the intelligent power module, and then the rest of the assembly that contains the boost inverter and the IGBTs and the coolant passages and so on. all of these that we've looked at so far, the Chevy Volt, as you can see right here, there's 2 coolant hose fittings. The Ford Fusion, 2 coolant hose fittings. The 2017 Toyota Prius Eco, the one with the lithium-ion battery, 2 coolant hose fittings. These are all liquid-cooled inverters. They run really hot. They have their own dedicated coolant system. The DC to DC converters that are in the back of the vehicle, those are just air-cooled. Okay, so that's 4th generation Toyota Prius. Then the next 2 inverters, these 2 here, they look like twins. These are 3rd generation Toyota Prius. But if you look closely, this one's called a Type B inverter, and that one, or inverter converter assembly, and that one's the Type A. If you notice on the Type A over there, it has a label right here that this one does not. And on a Type B, this one has the label right here that that one does not. But they also have a coolant hose on each side for keeping it cool. So in the bottom of this, we have the DC to DC converter and the boost converter module and the big reactor coil in there that's used to bump the voltage up higher than what battery voltage is. Inside of this, we've got the IGBT module that can be replaced. With the Coolant Passages, we've got the intelligent power module, the computer that's in charge of that, and some internal circuitry that can also be replaced. And then if we go down a little bit farther, this one right here is 2nd generation Toyota Prius. It also is liquid cooled, and it has pretty much the same serviceable internal parts that the 3rd generation Prius inverter converter does, except it breaks up some of those parts into smaller individual pieces rather than combining them. And then if we go all the way back to the 1st generation Prius, that inverter with DC to DC converter module right there has the same function, but it breaks up some of those parts that were in the 2nd generation one into even more individual pieces. Okay, there's one more thing I want to show you before we look at the internal parts and components of these inverters, and that is the common electrical connections that they have. So starting here with this old original Toyota Prius inverter converter assembly, these 2 wires right here, these 2 are the high voltage battery connection from the trunk. We've got the positive cable and the negative cable. Then these 3 wires right here that are cut off, obviously, powered the motor generator number 2 that propelled the vehicle. And then these 3 wires right here that make an electrical connection up underneath here with this connector power MG1, the starter and generator portion of the inverter converter. And then we have all these electrical connections right here. All of these connect to the high voltage ECU. So over here, underneath the high voltage cables, we have the low voltage cable. This is the positive cable coming out of the DC to DC converter, 14.5 volts, 100 amp output. But that's just the positive side. We need a negative side also. So this cable over here that every one of these inverter converters have, just for the low voltage system. That cable has nothing to do with the high voltage system. Provides the ground that connects to the negative battery terminal at the back of the vehicle through the vehicle body. And then we have an electrical connector to control the DC to DC converter right there. By the way, these original first 2 generations of Priuses also had an airbag discriminating sensor. One of the 2 sensors required to set an airbag off. These are mechanical sensors. It took a discriminating sensor, one of the 2 in the front, and an arming sensor, which was in the passenger compartment, to close at the same time to set the airbag off. There is a vent right here that allowed air to go in and out of the inverter converter assembly as it heated up. On the second generation Prius, almost identical. We've got a single wire harness coming out now rather than these large 4 electrical connectors that connects to the high voltage ECU. We still have the airbag discriminating sensor. We have the negative and positive cables that connect to the high voltage battery in the trunk. We have the 3-phase cables that connect to MG2. And in the front of this, we have the 3-phase cables that connect to MG1. We have our 12 or 14.5 volt output from our DC to DC converter right here. We have our inverter control wiring that hooks to a computer. And then right here, this second generation Prius was the first one to have an electric air conditioning compressor. So we have control wires for the AC compressor controls, and all of that is built into the DC to DC converter. So in the front up here, that orange cable, those 3 orange wires right there in that orange connection, that goes to the air conditioning compressor that's bolted to the engine. But there is no fan belt connected to it. All right, here we have the third generation Prius. We have the 2 wires coming in from the high voltage battery. We have 3 wires going out for MG1, for MG2. We have our DC low voltage 14.5 volt output right here, just the same as the previous ones, but obviously everything is smaller. And then on the third or fourth generation Prius, we have our 2 wires coming in from our high voltage battery in the trunk. This connector here is for the electric air conditioning compressor. This is the wire harness right here for that will just plug right in and be bolted down at that point. There's an electrical connection right here that connects to the high voltage ECU. And then on the side here, there's one great big opening that connects to the MG1 and MG2 electric motors. And there's also a high voltage interlock in there to disconnect the system. All of these have the interlock. There's an interlock under this cover right here on the third generation. There's an interlock under this cover and under this cover right here, high voltage interlock circuit. So all of them, as you disconnect the high voltage DC cables, have an interlock somewhere that disconnects them. All right, let's look at the Ford Fusion inverter. We've got the 2 wires, 2 sets of 3 wires going out to power the 2 motors in the HF35 transaxle. There's an electrical connection right here for the DC high voltage battery, and the AC compressor, I believe, is this. Nope, it's in the front, I believe. All right, and then here on the Chevrolet Volt, we have DC on this cable here from the high voltage battery. And then we have an output to the air conditioning compressor right there. And right here on the side, 2 3-wire connections to run the 2 electric motors inside the 4ET50 transaxle. And then we have our electrical connection here to an external computer that controls the inverter. We've got a connection right here on the first generation Prius and the second generation Prius. We have some bleed screws for the coolant system. So this one has 2 screws right here. This one has a hose that connects to the transaxle, and it lets you bleed the air out of the cooling passages in the transaxle. This one has a hose that just comes over here to the coolant pipe for the converter assembly and lets you bleed the air out of that. And then the second generation one just has a single bleed screw just for the transaxle. They got rid of the one for the inverter converter assembly. So let's take a look at the original Toyota Prius inverter converter assembly, and then I'll explain how all of these other inverter converters have combined some of those original parts and just made them smaller but doing the same function. Okay, we've got the 2001 through 2003 Toyota Prius inverter with converter. Converter's in the bottom, inverter assembly's in the top. Inverter takes DC power, inverts it, makes three-phase AC power in this instance. There are inverters that you can put in your car that take your 12 to 15 volt DC and invert it into a single phase 120 volt power supply for you to plug something in your vehicle. For removing this from the vehicle, as I've already shown on the 2010 Prius, we just need to make sure that we pull the service plug grip and make sure that there is no power from the battery to the inverter converter assembly. Now on the back of the inverter converter assembly here, we have two big electrical connectors for the high voltage battery. So I'm going to disconnect the DC voltage connection. There's a plastic tab I have to push down on and pull back. I'm not quite strong enough to pull back, so I'll give it a little pry there. And here we go. It's a shielded DC cable. This first generation one is the only one that has a shielded DC cable. If you look closely at the wire end there, you can see the shield around it. So that's the positive cable, or that was the negative one, and here is the positive one. Get that out of the way. Then down below over here, I've got the 12 volt connection for the DC to DC converter. It's our 100 amp 14.5 volt output. We have the electrical connection for the controller for the DC to DC converter that connects to the high voltage ECU. Then here on the driver's side, we have the discriminating airbag sensor. We pull back on the little yellow plunger and unplug it. And then we have 4 electrical connections that connect the inverter converter assembly to the high voltage ECU, and these are all connections that are part of the monitoring the voltage levels on the output on the three-phase cables and controlling and watching the voltage levels on the insulated gate bipolar transistors. These plastic electrical connectors are they're pretty brittle the older they get, so be careful as you are unplugging them that you don't break them. These are weather-sealed electrical connections, which means they're meant to keep water that splashes on them from intruding into the electrical connector, but they are not made to be sprayed with a high-pressure car wash. So don't spray electrical connectors directly. All right, we've got all of the electrical connectors disconnected, and we've got the 2 coolant hoses, one here at the reservoir and one down front there that hooks to the transmission, the transaxle. So we would want to drain the coolant out of the vehicle also, not the engine but the electronics coolant, which has a separate drain, separate portion of the radiator. On the big heavy three-phase cables that go from the inverter converter assembly down to the transaxle, on this connector right here for MG1, we have to undo the two bolts that go all the way down and connect to the connector itself. And that disconnects, of course, the discriminating sensor of the airbag. So we'll set that off to the side. There's a lid right here that as we lift that up, it disconnects a high voltage interlock circuit right there. That should open circuit the contactors if somebody forgot to turn the key off, or if there was a problem with the vehicle electrical system and somehow they were stuck on a bad contactor. And then we've got these three bolts right here that go through here that we would remove the bolts and pull that cable down and out of the way. Okay, on the back of the inverter converter assembly here, we have four number 30 Torx head bolts that we've got to take out to get to the three-phase cables that feed motor generator number 2, the one that propels the vehicle down the road. So we get those four bolts out and lift up the cover. This cover, as we lift it up, also has a high voltage interlock circuit on it. So if somebody took this off and didn't know what they were doing, they weren't proper trained, it should open circuit the contactors that we talked about and disconnect the DC power from the inverter converter assembly. Now when you disconnect the inverter converter assembly from the high voltage battery, they tell us that you should wait so many minutes to allow a big capacitor in here. It's called a smoothing capacitor that smooths out the rippling voltage from the generating portion of MG1 and MG2. There's a resistor across that big capacitor that will slowly discharge the capacitor, but it'll take a certain amount of time to be able to discharge that. I haven't seen a time that was any longer than 10 minutes though. Next we have three bolts that make the electrical connection from the three-phase cables to the bus bars in the inverter converter assembly. And so we'll take those out. And then there are three 10mm head bolts that hold the cables to the inverter converter assembly housing. These cables are individual cables. They're not all hooked together like they are on later model Priuses. I like to use Ziploc bags to keep everything organized when I take something apart. Also, the very first time I take something apart, I take a lot of photographs. And I'm talking a lot. Like every time I take a piece off of a transmission or an inverter converter or whatever I'm disassembling, I might take a photograph at that point just to see what it looked like before and after, because sometimes there are no good instructions in the service information, and sometimes there are, but there's nothing like documenting how it actually was when you took it apart. So I've just taken out what's called the U phase cable. There's a W, a V, and a U phase of the three phases, and so that cable is disconnected. This would go down to the transaxle, but it's been cut off because I purchased this from a salvage yard. So here's the V cable and the W cable. The salvage yard just cut all the cables and sent it to me, which I wish they would have disconnected them, but then we run the risk of internal contamination when you have somebody else unbolting all of this stuff, and you could possibly get water in there. The Ford Fusion inverter I have down there was clear full of water when I got it, and you could see where it had corroded a lot of the parts, and it was totally unusable. It works good for a demonstration for my students, but it wasn't. It certainly wouldn't be a usable part. All right, so we've got all of the electrical connections disconnected, and now we are ready to take off the cover of the inverter converter assembly. Now, sitting right here, this red mat is an anti-static mat. And that anti-static mat has a ground wire that you, just with an alligator clip, you clip it to your workbench. I've got it clipped to a metal leg of this table, just something that has a lower voltage potential than your body has. And then it has a wrist strap here also that will ground your body to that same wrist strap, and that will, or to that same ground, and that should protect the sensitive electronic components inside the inverter converter assembly from electrostatic discharge from your body. So now we've got, as we're taking this off, it has a bunch of 8mm head bolts. I'm going to use an electric impact, but I'm going to not just go full throttle and rip threads out of everything. I'm going to break it loose and slowly back them out. Steel bolts in an aluminum housing. If you give it full throttle on your impact, electric or air powered, you are asking to rip some threads out with it. All right, now we'll lift up. Did I miss another one? Yes. That's what I get for doing it behind here. There we go. Now we're going to lift up carefully. Oh, one thing, before you take any covers off, I forgot to mention this, everything needs to be clean. You need to get the dirt, the dust, leaves, whatever off, and try to prevent the best you can any of that from getting down inside the inverter converter assembly, especially if you're working on it in the vehicle. If you're working on it externally like this and you're going to take the whole thing apart anyway, like I am, you can clean it afterwards. But if you drop anything down in there, they recommend that you get some tape, like this blue masking tape here, and use the sticky side to try to pick up whatever particles happen to have fallen down in. So as we lift this up, we want to make sure that we don't get a bunch of garbage down inside of the inverter converter assembly. So here's our lid and the bolts that go with it. All right, let's look at a few parts while we are here. We have three great big smoothing capacitors, and here's that resistor I told you about that will drain. All of these are bolted in parallel with each other, so if you discharge one, it's discharging all of them with this DC bus bar ground, or DC bus bar that's there. We have the signal processor / protective function processor, this circuit board right here, that interfaces with the high voltage electronic or high voltage Yeah, the high voltage ECU, the electronic control unit. So this wire harness comes in and plugs in right here on this gray electrical connector. The next thing that we have two orange connectors under here. And of course orange means high voltage, but we've already disconnected the high voltage battery. We've waited the proper amount of time to let the capacitors discharge. It would be a smart idea to grab a multimeter and put across the capacitors before you touch them with your fingers, just to make sure that they are discharged. Okay, I'm on DC volts. I'm just going to come in and measure across. I've got 0 volts, and so it's safe to touch those capacitors. All right, I'll get my ground strap back on here. Okay, our next step is to disconnect all of these electrical connectors. They all have a little tab on them. These orange high voltage ones are underneath. Come on. There we go. So this one is for MG2's voltage circuits. This one is for MG1's voltage circuits. There are 2 current sensors in the inverter converter assembly. We have a MG2 current sensor, which measures how many amps of current are being fed to the MG2 motor, and then we have another one over under this plate here for MG1. So we have MG2's current monitoring circuit right here, and MG1's current monitoring circuit right there. And then we have MG1's transistor, the high power transistor controls, the IGBTs, control circuit right here, and MG2 control circuit right here, and then the interface with the high voltage ECU that is under the dash on these Priuses right there. All right, so we've got all the electrical connectors disconnected except for this eyelet right here. And now we will come in not with an impact gun, but just a non-insulated. We don't need special personal protective tools on this system because it has no voltage, high voltage. Nothing's dangerous on here at this point. So we're going to unbolt the circuit board wearing this ground strap so we don't damage it. And get it out of the way. All right, I believe that's it. Let's lift up. Oh, we've got a connector, or a plastic tanged connector right here. We have to squeeze the little locks on the other side. So squeeze the locks, pull that out, and now we're ready to lift up. Always try to avoid touching the circuit board or any of the electrical connectors, the pins themselves. Don't touch any of that stuff, especially if you don't have a ground strap on. So we are going to set that just right over here on the electrostatic discharge mat. And then the next thing we are going to take off is this big pack of capacitors. I got bolts out of the plate that it's in, but there are 6 electrical connections to a bus bar right here that connects. If we follow, let me get these wires out of the way. Here's our DC negative and positive posts right here from the high voltage battery. Notice those wires come right in and connect directly to the bus bar that the capacitors are connected to. So we've got to disconnect not only the high voltage electrical connection from the battery, but we've got to disconnect the capacitors from that. So there's a nut for the negative cable, a nut for the positive cable. There's 4 bolts that hold this electrical connection to the case. Okay. Get a Ziploc bag for the connector and the bolts. This orange electrical connector, if we lift up on the 2 wires from the battery, it doesn't just fall out because it's got the shield ground connections right there. Remember, the 2 cables coming in were shielded, so it's got kind of a crimp or spring-loaded fitting there. So now we'll set those off to the side. Now we can undo the 6 bolts that hold the capacitors to the bus bar. Okay, now I believe we can just lift up on the capacitor assembly and get it out of the way. I think I'll put those capacitor bolts in here with the high voltage DC connection. All right, next thing, this DC bus bar right here that was fed by the DC battery in the trunk needs to be disconnected. So it connects to 2 modules here. We've got this great big module that is the IGBT intelligent power module for MG2, the electric motor in the transaxle that propels the vehicle down the road. This other module is for MG1, the starter / generator. So they both need a DC connection with a power and a ground. So we have 2 wires coming in and then 3 wires going out on both of these modules. So the 2 big bolts I'm taking out now are the ones that feed power, voltage and current, to the IGBT module that runs MG2. And the 2 little ones next are the ones for the module that drives MG1, the starter generator. Okay. Now, right here, we have 2 other fairly heavy wires. They're not as big as the DC cables coming in from the high voltage battery, but these 2 wires right here, these are where the DC to DC converter underneath this whole assembly picks up its power from the IGBTs and the high voltage battery in the back of the vehicle. So now we can just lift up on this bus bar. It's a big, heavy, looks like it's nickel coated to avoid corrosion bus bar, and we'll put that in its own Ziploc. Keep it all separated. Okay, now we have several wire harnesses. Remember, all these connectors here that we disconnected, they got to connect somewhere on the other side. So this orange high voltage cable for monitoring the high voltages comes clear over here for the MG1 module. The driver control circuits for MG1 are over there. And then we also have another clip here, the current sensor for MG1, and then one more connection right here. This is actually the high voltage interlock circuit for MG1's electrical cover. When we took that cover off right here, these two pins opened up this circuit that also comes over to the high voltage interlock circuit for MG2. So if either one of them opens up, then it will it'll kill the high voltage battery. It'll by opening the contactors. Okay, so we've got that disconnected. So we've got the current monitor right here for MG1. So now we can come in and disconnect the three-phase cables, three-phase bus bars that feed MG2 and MG1. So let's do MG2 first. We'll disconnect the three heavy or bigger bolts. They're 12 millimeter head bolts. Yeah, 12s. So we'll get those out of the way. And then they come over here and bolt down to the electrical connector where the three-phase cables come in for MG2. So we'll get those out of the way. And then we also have MG2 current sensor right here. Let's get it out of the way at the same time. Just lift that up, pull the wire out with it. So we're going to bag MG2 current sensor, the bolts for the bus bar, the high voltage interlock circuit, and now we can rock out the bus bar for the three-phase cables for MG2, and we'll keep that here in the same bag. All right, now we'll do the same thing over here for MG1. It has its own bus bars right here. So we've got 6 bolts holding the bus bar that connects the wire harness for MG1 to the IGBT module for MG1. These IGBT modules, they have a full wave rectifier bridge with 6 diodes, just like a alternator does on any other non-hybrid vehicle. So a rectifier bridge takes the AC voltage and inverts the negative phase, makes it a positive phase, and then we use the big capacitors to help smooth that out. All right, here is the three-phase bus bar for MG1 and its bolts. And now we can take the electrical connector that goes with MG1 and remove it and get it and its current sensor out of the way. Okay, so get the interlock circuit wire and the current sensor wire right here for the MG1 electrical connection. And now I can show you how that would go up in and bolt together. Alright, so we'll keep all that in the same bag here. And then the last part to take out of there is the current sensor for MG1. Lift that and its harness that went up to that processor board. Bag all that up as one big piece. All right, we've just about got the upper portion disassembled. We've got a junction block right here with the 2 studs for the high voltage battery connection to three things: the DC to DC converter down below, the bus bar that feeds DC to both the IGBT module for MG2 and the one for MG1. Now we've got the wire harness on the side of the housing here. It's got a couple of bolts that hold that in place. It looks like they're captured bolts, so they don't come out all the way. They'll stick with the harness. And then there's a rubber grommet that holds that in place. There we go. Now we can rock out. There we go. Okay, so there's our complete harness, our interface harness between the internal circuit board and the external high voltage ECU. Set that off to the side. And now the only things left inside of the upper housing here are the two IGBT modules. So let's get those out. These have a 5mm hex head bolt that holds them on. These modules are what tend to go bad over time on these inverter converters. There's a couple of reasons they can go bad. One, the heat sink compound, the thermal transfer grease, whatever you want to call it, seems to lose its ability to transfer heat over time. And then some out of the factory didn't have the grease spread evenly, and so there was not an even heat transfer that took place, and that would kill some of the IGBT modules, and not just this model year, but future or later model years. Will clear up through the 3rd generation Prius. That's one of the reasons they're all serviceable, is there have been service campaigns to go in and replace some of these parts. It takes a very special thermal transfer, heat transfer grease to do the job. I don't know of a equivalent in the aftermarket world. The only place I'm aware of where you can get this stuff is from Toyota themselves. Okay, so I've got all the bolts loosened up. Now to remove these IGBT modules, they are going to have kind of, with that thermal transfer grease, they're going to have kind of a vacuum seal to stick to the heat sink that this coolant goes through to remove the heat from the IGBT modules. And it helps if you can slide it sideways just a little bit and then find a corner that you can lift up on and get that module out. Looks like I should have just taken the bolts all the way out. Oh, I missed one. No wonder. Okay. All right. Now I've previously taken this converter assembly apart and purposely cleaned off the heat transfer grease because it's such a mess for demonstration purposes. But right here on these three metal tabs here, it would be coated with, this was a white colored thermal transfer grease. There's a gray colored one that's used in some later models. And this flat surface here with the heat transfer grease fits right down flat on this aluminum surface here that I have labeled as the MG2 Intelligent Power Module heatsink. And right under this, as we'll see here in a few minutes, are the cooling passages that the liquid coolant goes through. So I'm going to sit that over here on the anti-static mat, and then we'll do the same thing with MG1's IGBT. We've got two heat sinks there and a big heat sink in the aluminum housing here to transfer the heat out of the module into the housing, into the coolant, up to the radiator, and then into the air is the cooling process there. All right, so we've got the upper portion all stripped out and gutted. On the side here is the coolant reservoir, and we need to take that off next to turn this inverter converter assembly upside down and take off the converter. So it just has, I think, 4 bolts that hold it in place. 4 bolts, 2 bolts and 2 nuts. You want to make sure that you don't get any coolant on the electronics. Make sure everything's pre-drained before you do anything. So this coolant reservoir here has an O-ring right here that seals to a passage on the side of the case for coolant transfer into the coolant passages underneath the heatsink here. Just bag that up. Keep everything organized. All right, we could unbolt this extension housing here, but there's really no point in doing so. So now let's turn this whole assembly upside down. Remember, the only thing left in here are the 2 wires, the DC high voltage wires that go to the converter assembly, where we take the 273.6 volts and step it down through a center tap transformer and output 14.5 volts. So let's turn this over. All right, I'm going to take out very slowly the bolts that hold the DC to DC converter to the bottom of the inverter housing. Normally, this is sealed with a special black form-in-place gasket sealer from Toyota, and it's a very good sealer and glue, which means you're not going to just be able to lift this up. There are pry points, these little tabs here, where you can pry up slowly. Don't go really quick on it. You got to pry up real slow and let that sealant break loose, because it breaks loose real slow. If you have patience, it'll work. If you force it, it'll just break the pry tabs off at the bottom here. So I've already taken this one off. And so let's take this out and look at it. So here on the bottom of the DC to DC converter, we've got a kind of a flat plate, but you can see some guide lines there for the coolant. And then the DC to DC converter is under this cover right here. this whole thing is just serviced as one assembly. So you can buy the DC to DC converter. So if your 12-volt battery keeps going dead and you do the voltage check with the vehicle powered on and you're not getting 14 volts, 14 to 15 volts at the battery, the low voltage battery, and you don't have any other trouble codes, chances are really high that your DC to DC converter is bad. And you can buy a DC to DC converter and install it. It's a lot of work, but it can be done. All right, the rest of what we're seeing here are the coolant passages. Let's see, the coolant would come in right here from the reservoir and then just make this serpentine. Looks like it makes 1, 2, 3, 4, 5, 6, 7 turns, and then and it's absorbing heat from these IGBT modules that are on top of it, and then it goes to the transaxle to cool it before it goes out to the radiator. So that's been a lot to disassemble, but I told you if you could understand this inverter converter assembly, then you would be able to understand the rest of the 6 inverter converter assemblies that I've got on the table here. So all of them are going to have some sort of a power transistor module for each electric motor that needs to be driven. All they did on the 2nd generation Prius is they took these 2 modules, the IGBT modules for the 2 electric motors, combined them into one big module, and then took this circuit board right here and put it on top of that. So that is one assembly. These 3 pieces now have been combined into one on the later generation modules. These 3 capacitors right here are now combined into one big capacitor. And there are other capacitors. I mean, this board has capacitors on it also, but there are other capacitors that are used for other things in driving the electric motors and receiving power from them during regenerative braking when you slow down. But they've combined the resistor and the capacitors into this one great big module, and we'll look at that here in just a few minutes. We're not going to totally disassemble the next one, but the next one actually has 2 additional pieces in it that this one did not have, that all of the other ones do have, to my knowledge, and that is called the boost converter and reactor. And as I tried to explain before, on the 1st generation Prius, they used a higher voltage battery to drive the transmission. On the 2nd and subsequent generation Priuses and Fords, they went with a lower voltage battery, but then inside of the inverter converter assembly, they bump up the voltage through self-induction on this great big reactor coil. And add another up to 300 or more volts, depending on what model year and vehicle it is, on top of the voltage that the battery supplies. So a 201 volt battery now can put out with the boost inverter can now put out 500 volts, which gives the transaxle more power, gives the vehicle more power, because the very 1st generation ones were a little underpowered. A lot of customer complaints about that. Okay, so that is the 1st generation Prius here in the United States inverter converter module. You can buy, as I said, the DC to DC converter, but to my knowledge, they don't sell these internal parts anymore. You got to buy the entire inverter converter assembly if you need any of these parts, or you could attempt to find something off of eBay, but just beware, there's a lot of garbage out there. I bought one of these off of eBay, and I opened it up, and the salvage yard I bought it from had taken a green paint marker and put their initials all over everything inside and outside of this inverter converter module, and they actually drew on the circuit board with this paint. And I suspect that it's conductive paint, which would totally ruin it. It's a good thing I only bought it for demonstration purposes, but look out. There's there's a lot of garbage for sale out there also, and you won't know about it until you get it. All right, let's look at the next generation inverter converter, but only as far as seeing what is different between it and this one, and then that will finish up our discussion on inverters, because they're all basically the same after that. Okay, here we have the second generation Prius, which is 2004 through 2009 inverter with converter assembly. So let's look at what's different on this thing. All right, same type of coolant reservoir, except it has a little nipple that sticks inside of the housing rather than sitting flush like the first generation one did. All of the bolts on the cover except this front one right here just have a 10 millimeter head. But that front one is a number 30 Torx for whatever reason, probably to keep most people that don't even have a Torx from taking the cover off. It's the only thing I can think of. Keeping the curious-minded people out. And if we miss another bolt, yep. All right, if we lift up on the cover, on the back side of the cover, or I'm sorry, on the front side of the cover, right here we have the high voltage interlock circuit. So as you lift off the cover, if you were untrained and had no idea what you were doing, and the key was still on, the contactors would, or should go open at that point. All right. Now, the next thing to remove is the wire harness right here, the external interface with the high voltage ECU. And it just lifts up and out. This would be part of the main vehicle wire harness under the hood and just sit right there. There's the positive post and the negative post, just like we had over there where our high voltage wires are going to come in, and so we can take those off. Never ever use an impact on anything that is connected to plastic. So these studs are embedded in a plastic piece that's part of the capacitor assembly. So this big capacitor, this big black block right here, replaces all three of those round capacitors on the first generation Prius. Now we can undo our high voltage lines coming in from the battery. Here's our high voltage wires, and then just like on the other Prius, we've got a red and a black wire right here that go down to the DC to DC converter. All right, and we've got another electrical connection, just two more electrical connections, and then straight down right here I have a bracket that holds the electrical connections in place. Out. Okay, next we'll take off the capacitor assembly here. And it has connections everywhere. So there's the 4 hold down bolts that hold the whole capacitor assembly to the housing. And then we have 2 bolts right here that are the DC connection straight from our high voltage battery. And then we have a single connection to a new part that we've never had before in the previous Prius called the reactor. And it's just a great big coil of wire. It has 373 microhenries of induction capability. And then we also have a power and a ground DC from the battery to the boost converter module, the one that controls the reactor. So now let's lift up the capacitor assembly. This capacitor assembly actually has a capacitor right here, a big capacitor right there, and another one built in over there. So there's 3 capacitors, 1130 microfarad, 282 microfarad, and 0.1 microfarad, where all of the previous ones were 2700 microfarad in the previous generation inverter converter. All right, now this great big module right here is what I was trying to describe to you before. The 2 separate IGBT modules from the first generation Prius and the circuit board make up this giant piece right here. Ooh, I'm supposed to have my ground strap on. We have DC power coming in and out here from the high voltage battery, and then we have 3-phase connections going to MG2 back here, MG2, and then 3-phase connections going to MG1 in the front right there. I'm not going to take any of that off because it's the same as what we've already seen in the previous generation. But these 2 parts right here, this big inductor suppressor, which we've got a ground, it's ground controlled. So we had battery positive from the high voltage battery connected there. This module controls the ground side of that. And then these modules also are held down with a heat sink compound. This boost control module can go bad from inadequate grease or just overheating over time. Let's say you've run low on coolant and it's just overheated. It should have the heat sink compound underneath it. It's got the heat sink right there. It's got the same serpentine cooling passages that we had on the other one right there. And then the big inductor, it's just a giant coil of wire, big heavy coil of wire, because we have to handle a lot of current on acceleration and deceleration. I don't know the exact amount of current. I know the battery service plug grip has a 150 amp fuse in it, but that's DC. Alright, so here comes the big inductor. Get the bolts out of it. So the inductor here, it's got 2 electrical connections there that go to the big coil of wire. So this terminal connects here, this terminal connects here. We pulse DC current through it, it produces a huge magnetic field. Then we release that pulse. The magnetic field collapses on itself and through self-induction creates a reverse polarity up to 300 volts, pushing current in the same direction that the high voltage 201.6 volt battery is already sending it. And it needs heat sink compound for its heat sink down there also. So the boost converter module and this big coil of wire, the inductor reactor, these are what they added to the inverter converter here from the first generation to bump up the voltage. And all the subsequent generation Priuses and any other Toyota hybrid, the GMs, the Fords have these boost converter modules in them. It's a great way to increase power without having a monstrous high voltage battery. Okay, the other thing we need to look at that's different on this inverter converter assembly is this orange electrical connector up front. It has 3 wires, so it's a 3-phase electrical connection to the air conditioning compressor. Now the later model inverters only have a 2-wire connection. They supply DC, high voltage DC power to the AC compressor, which then has its own inverter internally. So these are some expensive air conditioning compressors to change it to 3-phase AC and drive the electric motor so that you can have air conditioning when the internal combustion engine is not running. On the first generation Prius, if you turned on the air conditioning, it would not go into idle stop. The only thing left is to look at the parts inside the inverter or inside the DC to DC converter. I have one that's already removed from the housing, so we don't have to remove it. So let's go look at that next. Okay, so right here on my classroom wall, I have the inverter converter, the DC converter portion of that second generation Prius right here. And the upper portion of it right there is the air conditioning inverter, and you can see those 3 wires that come out and come down to the electric air conditioning compressor. The lower portion, the DC to DC converter there, as you can see, has a transformer right there, 2 wires in, 2 wires out, and then a inductor, a coil of wire there, 1 wire in, 1 wire out, and its own driver circuit right there to take the high voltage DC and convert it to low. Here's the schematic for the DC to DC converter. As you can see, there is a center tap transformer and 4 power transistors and diodes for controlling the DC output. Over here is the air conditioning system inverter schematic, and it has its own IGBT as part of this lower DC to DC converter that then drives the air conditioning compressor all by itself. And then here's the schematic for the second generation Prius, 2004 through 2009. We've got the electric motors at the top, the 2 sets of IGBTs and transistors right there next, the boost inverter power module and the reactor coil, and then the high voltage battery, and then the DC to DC converter and the AC converter and the external high voltage ECU. Okay, that was a lot to cover, and that was cutting it way down on information because there's so much information here that we could go through on these inverter and converter assemblies. And maybe in future episodes when we talk about each vehicle manufacturer platform, we can look at their inverter converter assemblies along with their batteries that are unique in future episodes here. But amazing technology, and it's stuff that you as a service technician can, if you're patient and clean and can read and follow technical written instructions can make additional money doing. But it could also be a very expensive disaster if you aren't following the instructions or don't have the proper training and so on. So this has been basically a summary of inverter converter components, operation, and service. What's serviceable in these. And the second generation Prius, almost everything. Well, I think every part in there of the major parts is something that you can buy from the Toyota dealer. All right, thank you for watching.